Okay, hi Devin. This is our presentation on coronavirus, and we decided to focus on the death toll in Brazil.
Okay, so just for some context, the first recorded case of COVID-19 in Brazil was on February 25th, 2020. They have the most cases and deaths in Latin America, and due to the president's lack of concern for the virus, hospitals are understaffed and they're also reaching full capacity. Um, while the president argues that um, Brazil has already passed the peak number of cases, several health experts argue that the worst is yet to come for the number of cases and deaths in Brazil due to COVID. Um, and yeah, the president is just doesn't believe in social distancing and thinks it's ineffective. And that's reflected in the number of cases that there are. Now, finding our data.
Okay, so we collected our data from covidly.com, which showed the increase in the amount of deaths every day. So we split our data into 3 columns, which was date, day, and death toll. So immediately we figured out that this is not an arithmetic sequence because there's not a common difference. So that left a geometric sequence. However, by simply looking at the data, we couldn't discern a common difference. So what we decided to do to find the common difference and the rate of change was to find a line of best fit so that we could extract the rate of change from that, so that we could gauge what that rate of change would look like from that equation. So we chose to use an exponential function because it most resembled our data and would provide the most accurate results. Okay, so to the right, you can see our points graphed and the line of best fit that we found. And clearly, like, there's a very strong correlation. Our equation was y is equal to 80.5 e to the 0.094x. So our r squared value was 0.987, which also indicated that it was a really strong line of fit. To kind of get rid of e and to find our common ratio, we multiplied e by that 0.094, which gave us the roughly 1.099 for our common ratio. So then we use that ratio and that initial starting value of 80.5 to create an explicit geometric sequence, which is a to the n is equal to 80.5 times 1.099 to the 9 to the n minus 1. Just notice that we switched x for n because it's an explicit formula. And also, it's important to note that our starting value in this equation is not the same as our data, which was started at 0. So that's important to note that there's that difference, but we can't change that 80.5 to 0 or else it completely changes the accuracy of the common ratio and that line of best fit. Yeah. Okay, so for our equation, mathematically speaking, our domain would be 0 to infinity because it is an infinite geometric sequence. However, in context, we have to look at the domain in terms of COVID-19 and its numbers. So it would resemble more of a finite domain, because you can only use the data for the number of days that you have, and each day that domain is going to change to compensate for that extra day. But our range that we worked with technically was 0 to 49. Okay, or our domain, the range of domain. Okay, so then our range is 0 to infinity. And again, in terms of our explicit equation, it continues to infinity, but you have to contextualize what's going on, and that there are a lot of other factors at play, such as social distancing, potential vaccines that will change the rate of death in Brazil. So there may be peaks or declines in those numbers that the equation will not be able to account for. Bella, do you want to do end behavior of the sequence?
Yeah, so the end behavior, as x approaches infinity, y also approaches infinity. And as we can see on the graph, yeah, just as x is increasing, y is also increasing. Like Ava did with the domain and range, to put it in context, it will eventually plateau, and so it won't be approaching infinity at a certain point. But with the data that we have and the line of best fit, the exponential line of best fit that we have, x is approaching infinity, and so is y. And then as x approaches 0, y also approaches 0, and that's just because our data starts at 0, 0, so day 0 and 0 deaths. So that is why that's the end behavior for that. If we had data that was converging, then we would be able to, converging, we would be able to find a sum, because the numbers would be small enough where we would get like an accurate number. But because our common ratio is above 1, so it's increasing and won't stop increasing, and it's increasing by like significant numbers, we can't add it together because it changes and the numbers are too big. Also, our data that we chose, we didn't do each day's individual amount of deaths. We did each day adding on to the previous total deaths.
Yeah.
So if we did do the first option, the sum of the sequence would reflect the number of deaths over time. But because our data already reflects that, this would be more representative of how many days, this is really morbid, but like how many days that number of individuals have not lived. If that makes sense. Yeah. Okay. So how could the data change? So basically how COVID-19 works, and also how viruses work in general, is that eventually there will be the data will plateau at a certain point, and eventually, hopefully, we'll get no new deaths, so it'll stay at 0. This would still not be a convergence, because a converging sequence is reaching a certain number, and if the data, let's say the data caps out at like 10,000 deaths, because it's staying stagnant at that value, it's not going to be converging because it's not reaching a number. So just an overview. So our, as we've said previously, our equation for a line of best fit is reflective of how Brazil's COVID-19 death rate is increasing right now. But it will change because, like we both said, it's going to plateau at a certain point. And because it hasn't plateaued and it hasn't peaked for Brazil yet, we couldn't find a line of best fit for that. But this is most reflective of the exponential growth of Brazil's death rate before it's peaked. And then finally, why will the data eventually plateau? Why will it not just keep increasing? Well, there's, in the worst case, is everyone's going to die from the virus, and then there's no one else to get it.
Okay. And die.
So that's one reason. Another reason why it would plateau is society will adapt, and things like social distancing, where we are kind of adapting to life with a virus, and not everyone's going to get it, so not everyone's going to die from it. And then also, just because of these precautions like social distancing, it'll slow down the spread of the virus, and limit the amount of deaths, and also things like vaccines, which hopefully in the near future, that would help a plateau.
Can happen. Yes.
Yes.
Cool. Okay. Thank you.
Great. Okay.
Here are sources that you can look at if you want. Cool.
Okay. Cool. Great. How do I stop?